and you're here today to learn about harnessing the power of digital data, new tools and methods for measuring, mapping, and modeling in urban environments. So just a quick preview of what we'll be looking at today. We'll just welcome our speakers. We'll be giving you an overview of remote sensing from a LiDAR perspective. We'll be looking at some of the improvements in the technological field of LiDAR and sensors and give you a sense of where this industry is heading and what's at the cutting edge. And we're going to wrap all this up in some interesting stories from the project work that AppGeo and Sanborn have been working on recently or completed recently, along with some ways to really apply the knowledge that you learn here today, not just at the theoretical level, but ideally in the projects that you may find yourselves involved with now or in the future. And of course, we'll have an opportunity for a Q&A with our experts on the call today. So just to give a quick welcome to our speakers, we are joined today by Jared Martin, who's a VP at Sanborn. He's really the expert in all things when it comes to remote sensing technology within Sanborn. His list of experience is quite extensive, as you can see here. And, I've been getting to know Jared over the past few weeks, and it's been a really great resource to have on the team. And he'll be answering and explaining all sorts of aspects of LiDAR technology and aircraft systems, anything that flies or takes pictures, he's basically an expert on. And we are also joined today by Brian Coolidge. He's a project manager here at AppGeo who has been in the GIS industry for well over 20 years. And I've had the pleasure to present with Brian in the past on some of the topics that we're looking at today. And he's really a wealth of knowledge when it comes to project management, GIS project design, and a lot of the topics that we're going to be uncovering. So welcome, Brian and Jared. I just wanted to give you a quick background on Sanborn. Some of this is new to me as well, but what's really exciting about Sanborn is that they've been in the mix for over 150 years. They are a name that is really synonymous with mapping, and throughout that history, they have developed and been pioneers in a lot of different technologies, as you can see across this timeline. And their experience with LiDAR goes all the way back to 1998. I was probably 6 years old at that point. So just gives you a sense of how long they've been working with this technology. And I think it's going to be really interesting today to see what's different from then to now and what is in the years to come. So very exciting stuff. And with that, I kind of want to just open the conversation with a very what might seem like a basic question, but I'm sure it's not a basic answer. And that is, what is LiDAR? I'm sure many of the folks on the call today have heard the name and maybe are active users, maybe have seen some of the data products, but I really want to center our conversation around what is this technology, what can it do, and what are some of the data sets that come out of LiDAR. So I think I'll start by handing it over to Jared just to give us a really quick background. And then I imagine we're going to be connecting it to some of those projects that we've been working with.
Yeah, thank you, Aaron. I'll try to keep it brief and from a very high 35,000 foot view. But LiDAR, what is it? It stands for light detection and ranging. For those who are unfamiliar, it is an acronym. But in recent times, the USGS has really been promoting the fact that it is a common noun. It's gone along the same route as sonar or radar, and it's just a word that you can use that everyone knows does some form of remote sensing technology and can identify objects through the technology itself. It is an active sensor that will use light in the form of a pulsed laser to emit laser beams and then measure the Earth that it flies over in terms of airborne. Basically, it is a very highly advanced rangefinder that is emitting, at this time, millions of pulses a second to measure everything from trees, buildings, ground, and even now getting into water and below water. to get kind of that seafloor observation. You combine the technology with your GPS, GNSS, and IMU sensors or inertial measurement units, the same thing that you have in your phone to tell you which direction you're going or how you're playing your video games on an app, but at a very higher scale. And that combines into a three-dimensional point cloud that allows us to basically, at a high density, walk through the earth in a digital form the same way that you would in a video game or some sort of simulation, VR, augmented reality. And that can be mounted on anything from an airplane to a truck to a train. You can put them on tripods. And even in more recent times, the big buzzword has always been UAV. You can put them on small scale, and it's becoming a much more consumer grade product where it's not just available to those who have millions of dollars and a large aircraft to mount it in to go and fly a large area. You take all the data that comes back, and the thing that makes LiDAR so interesting as opposed to just capturing imagery or just capturing some form of satellite and pulling sources down is with LiDAR, you're able to see more than what you can see with the eye. What I mean by that is in terms of vegetation, especially when you get into forestry, wetland areas, you can get pulses through the vegetation itself. It penetrates the canopy with multiple echoes or returns of that light beam so that it gets the top of the tree, it gets in between the tree, and it gets all the way down to the ground so that you don't just get that surface. You get everything down from bare earth up to the surface, which allows you to do so much more from an analytical perspective. You get a better picture of what's going on in your vegetated areas. And that translates to every kind of land cover, whether or not that's urban, suburban, completely rural, or your forest tracts. It allows so much more to happen when combined with other technologies like your imagery to where you can get an even bigger scope or a larger swath of information for any kind of project.
Well, thanks for the brief background there. I think it's a technology that a lot of people have heard about, but then when it comes to putting it into practice, it can open up a lot of questions. And I think that's what we're hoping to uncover today is how to think more intelligently about LiDAR as a tool in our pocket to approach some of the questions that many of our audience today are seeking to answer. So with that in mind, I'd like to take a step back for a moment and bring it over to Brian's side, where we recently have completed some work in Cincinnati, Ohio. They've been a client of ours, and that was a project that really heavily relied on LiDAR data at its core. So, Brian, I was hoping you could give us a little bit of background on that client, that project, why they came to us, and some of the things that we were able to help them with initially. And my hope here is that as we go through our conversation, we can take that lens of thinking about this particular project and what they were aiming to do, and then plug in some of the capabilities of LiDAR as we go to really form a solid grasp of how this technology is so beneficial.
Great, thanks. Thanks, Aaron. So Cincinnati, like many other big cities across the U.S., are really interested in what their tree canopy brings to them. There's a lot of lot of benefits to what tree canopy does, and Cincinnati, like a lot of these other cities, really understands that. So they were really looking to develop a new tree canopy layer as well as a land cover layer to help support an urban tree canopy assessment. So AppGeo has partnered with several other well-known firms. One is the University of Vermont, their spatial analysis lab, which actually helped develop the Forest Service's tree canopy protocols, as well as Save a Tree, which is a national consulting company. So we have an arborist on staff too to kind of talk with us about in the client with all things trees and how these assessments can help them. But AppGeo had currently, right prior to Cincinnati, had just come off a large project developing a tree canopy work for the city of New York, which, as you can imagine, is one of the most complex urban environments that we would find in the U.S. So I think that helped us with our credibility going into Cincinnati and working for them. But ultimately, Cincinnati was really looking to start with collecting their own data. A lot of projects that we have may use existing data to do this. Cincinnati wanted, to have the most recent and current data that they could to help inform this process. So they had looked to get LiDAR collection as well as imagery collection to support this. And traditionally with these urban tree canopy assessments, imagery, a lot of this data is extracted from imagery, but as LiDAR continues to advance, it becomes a really unique and great tool to use to help support these projects. So as we were talking to the city of Cincinnati, we said, hey, we think that we could do a really good job on this project using a LiDAR collect that's recent, but as well as using something like National Agriculture Imagery Program data. Is, if you're probably all familiar with the the federal government collects and flies these images so that we can actually get tree on or leaf on conditions throughout the country. So we knew that combining the LiDAR with the NAPE data would really give us a really good urban tree canopy assessment for the city. So one of the things that we would want to do with that, other than obviously collect new land cover classification, but also evaluate the gain, loss, and no change in canopy throughout a 10-year period from 2011 to 2020. So a couple of things that urban tree canopy was going to help the city inform was they were looking for a 40% goal in tree canopy citywide. The goal was met. They found that they had 43%, which is one of the higher rates across the country for a major city. They were also looking for 40% in their residential areas. After this assessment, they found that 12 neighborhoods still aren't there. So this will give them a way to actually look at taking this data and look at how can they make better use of their trees throughout the community in these residential areas. Same thing with the mixed use areas. They were looking for a 25% tree canopy there. 6 of those communities within Columbus area, within Cincinnati, still aren't there. But again, they can assess and figure out how to get them there. And then they're looking for 10% in their central business district, which currently sits at 8%. So they're pretty close. So a couple other goals that they were looking, and one of them was to reduce flood risk throughout the community, mitigate rising temperatures due to climate change, and then as well as improve air quality throughout the community. So one of the other things that we did do, which was not initially part of the scope, but we kind of brought in, we had a postdoc fellow that was working with us that was able to bring in an equity background so that we could actually look at the environmental justice and equity with tree canopy throughout the city of Cincinnati. So I know we'll talk about that a little bit later. But they really wanted to look at, how does a tree canopy affect underprivileged communities?
Yeah, it's really fascinating stuff. And I think a key takeaway here is just how many questions we can answer with, a couple of data sets, really. So it's very powerful stuff when in the right hands. From here, I kind of want to go deeper into, LiDAR as a technology. We can see how it's enabling these really exciting analyses. But let's talk for a minute about some of those like downstream products that we've collected some LiDAR. What can we get as a result from that process? Because you mentioned land cover, tree canopy, and others among those for Cincinnati, and it seems like these are continuing to grow.
Yeah, Aaron, one of the benefits too is that with the LiDAR, it gives us a pretty good representation of the height of trees as well. So we can bring that as another metric into our analysis, as well as trying to help count the number of trees also.
Let's see, just looking for the next. All right, so yeah, as you mentioned, in Cincinnati, we had not only a tree inventory, but some characteristics of those trees, like height, species, and also as important as where they are is where they're not, and that's going to tie into that equity piece that we introduced a minute ago. So, like Jared, from your perspective, how does all of this tie into those additional layers like we can see here? I'm seeing flood and terrain modeling. So beyond the canopy itself, what are some of the aspects that we can pull out of these data sets that are actually going to be really helpful for cities?
Right. So with the technology, especially when you're combining LiDAR with other technology like RGB or multispectral imagery, the fourth band near infrared, you're able to take things that would just be a digital surface model or a digital elevation model, which is just the bare earth, and you're able to calculate additional attributes. You're able to get additional analysis like a canopy height model, where you take that tree height and you can identify not only where the trees are, but how tall they are. Then you can take that to an additional step and you can measure the individual canopies of those trees, which gives you an overall land cover percentage of how much vegetation you have covering the ground versus how much not. When you're able to extract everything in a three-dimensional form, you can take those trees and then you now know in relation where they are to the buildings. You have two-dimensional footprints, which can be easily extracted from imagery, but then you have a very highly accurate and relatively automated process to extract 3D building wireframes. And you're able to build those augmented reality scenarios. You can start combining data sets and you're getting closer into determining kind of a digital twin analysis where you go further down the line based on time, how they correlate and react with those things around them. You're able to then take where you have higher density trees versus non-density versus higher density urban environments, and that's when you get into kind of a heat island scenarios. Then you can really determine where you need to maybe put some more emphasis on your infrastructure, maybe some of your buildup on your project planning, just city planning, on where you need to fill a gap or a void, or where you can really improve some of that equity. It gives you a better perspective, and it doesn't just say, here's a picture with a bunch of lines drawn on it. Trust me, it's all there. You have this data set that is more than just data. It has so many other capabilities to extract other data from. You're able to build off of that, and it's a true sum of its parts. All the products that you're able to produce from these 2D and 3D data sets that then get combined into additional data sets really leaves the sky to be the limit. What do you want to get out of it? What do you want to assess? Are you trying to identify where you have water? Are you trying to identify where that water can go, or what might stop that water? Is there vegetation that is going to affect that? Is there any kind of buildup in, like you see here in this change detection? Did something change that is going to impede that water, or is going to impede the way that you have the vegetation growth from previous years? Do you know if the trees have grown for 10 years? Is there construction that wiped out all that? And then take it and identify over the years, depending on your different legacies of data, where it is trending and where that change is probably likely to occur next. Is there something that is going to be on the forefront of construction, or there's going to be permitting out over there, and you can kind of identify where that is going to change on your vegetation, your urban, your water, and you can see where it's going in the future, not just where it came from in the past.
Yeah, really fascinating stuff. And I definitely agree with your analogy there that it's very much like building a puzzle, right? You assemble all these pieces and suddenly you can get a complete picture. I just say one message in the chat. Please expand on the limitations of getting ground surface elevations. So we can probably cover that more in the Q&A, but I think it's worth, while we're on topic, surface elevation models are one of those data products. Let's see if I can bring up a nice visualization of that. So as Jared mentioned, there's all of these different layers that can come out of one collection. But what are some of the things that a client might want to consider when trying to build a ground surface elevation model in a variety of environments? They mentioned grass, prairie, forest.
Right. So like with anything, there are limitations to technology. When you get into tall grass, the prairie lands, the denser forests, you do have to consider the vegetation. You do have to consider the time of year that you are collecting this data. And then you have to understand that even if you have the most ideal scenarios, there's still technological limitations that you have to play with. In terms of tall grass in the prairie lands, where we are today versus where we were even 10 years ago, we are in a much better position to more accurately model those ground surfaces. The return separation, or what I guess the easiest way to explain that is for the amount of distance that's needed for the laser to travel in order to receive another return or another echo is down to below half a meter on some of these airborne sensors. Some of the even the UAV sensors, the unmanned, it's even smaller, has such a higher potential there that you're able to take the what would be tall grass, kind of that half meter, 1.6 feet. And as long as you have a little bit more than that, there is a much higher likelihood that you're going to get a return at the top of that grass and a return at the actual bare earth surface. Now, you still need additional processing to go through and accurately depict the bare earth versus the top of the grass, because when it's that close, there is a potential for it to kind of jump up and down and not give you a nice, smooth, accurate surface. So where we're at today is you still need people to look at the data. You still need to go through and make sure that what is accurate using ground survey and actual collection is what you are trying to get to. But it is much more possible today to get a better result than it was 10 years ago or even 5 years ago, honestly. In terms of dense forest, the obvious and best way to get through the dense canopy is to collect during leaf off scenarios. You have a more direct line of sight to the ground. You're still able to map the canopies of that vegetation, of those trees. They just won't be the same leaf off. And there's arguments to be said that leaf on is going to add more weight and distribution to those tree canopies. But if you're more interested in identifying where the trees are, how tall they are, and you want to know based on the ground, your leaf off scenario is your best bet. Sometimes you get the timing just right where the trees are just budding and you still have penetration through the canopy, but that's not always a guarantee. You can try to plan for it, but you have to kind of go with what is your best case scenario for all possible times of year, and leaf off is your best case. It's better now than it was, but there's still no guarantee that the technology is absolutely going to be where you want it to be yet.
All right. Sounds like people are loving your answers there, Jared. Absolutely. And keep the questions coming. I think it's great to have the resources we have in our conversation here to answer the things that you guys are interested in. But I do want to bring up a couple more topics from the planned part of the presentation. And that is, I know, Jared, you were just traveling internationally even to hear about some of what is on the forefront of technology when it comes to sensors and applications. I'd be curious if you could share for our audience today a little bit about, we saw what some of the capabilities are, but where is this industry heading? As what does the next 5 or 10 years look like, and where are we now compared to where we were, let's say back in the late 90s?
Yeah. So I most recently got back from Germany, where I attended AppGeo, which is arguably the largest geospatial and remote sensing conference in the world. It was quite large, a lot of technologies, a lot of analytics, a lot of different platforms of which to take our industry further. And to give it a little bit of perspective, when Sanborn first got into LiDAR technology, or when the first commercial sensors really became available, they were operating at a 5 kilohertz pulse repetition rate. And that equates to 5,000 points per second. And that was put across a swath, and it would scan, and you were able to get 5,000 points back potentially every second. One of the major manufacturers at AppGeo 2 weeks ago announced a sensor that is now at 4.4 megahertz, which is equivalent to 4.4 million points per second. So that is roughly 880 times the power of what we were operating when we first got into LiDAR. That allows you to fly faster, to fly higher, to collect more data at a much higher rate, at a much lower cost than where we were at 25 years ago. And it gives you the opportunity to do so much more. You don't have to get it all in one pass. It gives you more availability to deal with the different flight areas, the different environments that you're working with, whether or not that's somewhere as complicated as Washington, D.C., or somewhere a little bit less complicated from a airspace perspective. You're able to get in, get out, and get more than you wanted in most cases to do with that data. When you're combining it, the industry is moving towards a situation where your large format cameras and your large format airborne LiDAR systems are much more in sync from a footprint perspective of collection. That allows you to combine these incredibly high resolution, high fidelity, high density data sets to simultaneously collect, at the same time allowing for more information to come back in one pass or from one aircraft. You don't have to deal with putting multiple aircrafts in the air. You have to work with, oh, you can only fly imagery at this time, but you have to fly LiDAR at this time. You just fly it all together. And if that works out from a scheduling perspective, it's one and done. You got the data in the can, go home, and you can start processing all the possible analytics you want from it. Even with where the technology is going today, we know that where we're going to be 5 years from now, 10 years from now, is going to be so much further along. There's new types of LiDAR systems, not necessarily the linear mode, but you also have single photon. You have Geiger mode, where you can collect at a much higher rate of density at a much higher altitude. But it does have trade-offs. It might not give you the same accuracy that you want under vegetation, or you might not be able to collect it at the same time that you would with imagery, because unlike the linear mode systems, they typically operate at night. And while linear can operate at night, they're not limited to it. Hybrid approach is where we are going in the future, how you can use other forms of data like structure for motion imagery, SAR or synthetic aperture radar from satellite to get 3D data, and combining it with the LiDAR and the traditional imagery, you're able to get so much more into one package if you need it than you would maybe 5 or 10 years ago. So the future is looking bright. There's not necessarily following Moore's law. We're not doubling down every 2 years and anything like that, but it is constantly moving forward. Maybe just not to the same rate that it was when everything first started going.
For sure. And it sounds like, in my mind, thinking about the data projects that we have here at AppGeo, it's a constant race between, collection and then ability to process and store the end result, right? And even the intermediary results becomes kind of a big data problem very quickly. And having, an offload of hard drives of point cloud data, it could be the best data in the country, but having the ability to process that and get to those downstream products is really, I think, where the benefit to the end user is going to be. So from that perspective, I want to kind of go one step further and ask if a client is interested in approaching, a LiDAR collection, say they want a tree canopy layer for their city, as to stick with our Cincinnati example. How should they be thinking from the ground up about designing that project? Some of the things to keep in mind when scoping it or looking for partners, that type of activity.
Yeah, the first thing that anyone should look at when trying to design some form of program or scoping out what your use case is exactly what your end game is. Are you trying to identify the bare earth surface? Okay, that makes it real easy. Are you trying to identify maybe every single building in a municipality or the trees? Are you trying to get the trees along with the veg or the bare earth below it? Or are you looking for maybe something that is a low tide scenario around your water, or more of a drained wetland area to get a better understanding of the formation of that wetland, not just the water that is there? And you use that to identify not only the types of data that you want to pull out of it, or the sensors that might need to be used to identify that data, but you are able to identify the timing. Does it need to be leaf off? Are you trying to get through those trees? Does it need to be leaf on because you're more interested in the actual trees themselves, not exactly, the ground below it? You have to take into account the best time of year that you want to be flying this data that gives you the best opportunity without clouds. If a cloud comes between you and your aircraft and the ground, you're not going to see the ground. So where you have the least number of clouds is typically near winter, and that is going to be the best opportunity. You want to find not just, I want LiDAR or I want imagery. You want to find the sensors that maybe work best together because you want both. It's good to have some partner or a vendor that has access to not just one sensor type, or they're not only operating in one part of the country. Oftentimes, the hardest part is arranging the scheduling to be at the location of the project. It is very difficult to sometimes find the actual opportunity or the access into those airspaces. And oftentimes you find yourself getting access, but then the FAA or Tower Air Traffic Control decides, okay, you can fly, but you can't fly at the altitude that you wanted to. You have to now fly, 2,000 feet above it or 5,000 feet lower. And you need to be able to either change your sensor settings, change it so you can still get the data. So you're not just sitting there twiddling your thumbs, oh, we can't fly what we thought we needed to fly in our plan. You need to be able to have the agility to laterally move and adjust to whatever scenario is coming up. You don't know what the weather's going to be every day. You don't know the scenarios that are going to pop up, but you do know what you are trying to do. And you do know that if, in order to get the data that is required for that project to do the program and to assess it properly, you need to be able to take the different opportunities and attack when you have the time to attack. You can't just sit there. So experience is key. Relationships are very valuable, and the ability to get the data in the can correct and to provide the final in-game end goal is something that I know at Sanborn we always try to do. And if for anyone who wants to work in a scenario that they get the best data possible, they want to find those partners, have those plans, and then the contingencies on contingencies on contingencies if something were to change.
Absolutely. I think you were sharing a story about, it was at Washington, D.C., for example, like the constraints around the airspace there just sound fascinating and challenging to say the least. But, being able to adapt like on that day of, I think means having a lot of contingency plans in place and different variety of sensors available, even potentially.
Yeah, it really becomes invaluable when you get into a place like Washington, D.C. You're not just dealing with the tower. You have to coordinate with Secret Service sometimes. You usually have to have a law enforcement officer on board. And then whatever happens, if the president is on the move, you are not. So you work around that.
Absolutely. Pretty fascinating stuff. A pretty cool story to share with everybody. And Brian, I kind of want to bring you back into the mix here. Sorry, I've had Jared talking. So he just has so much cool stuff to learn. It sounds like going to our Cincinnati flyover, there was some interesting constraints with timing there as we were coming into the 2020 year and all the things that unfolded there. Like, tell us a little bit about what we learned from that process and how that actually ended up impacting the project out from a timing perspective, orchestrating all these flights and approvals and just equipment.
Sure, Aaron. Well, the nice thing was it wasn't nearly as difficult as trying to coordinate the airspace when we were working in New York City. Obviously, like Jared said, Washington D.C. is very difficult. Same thing with New York City. It's 3 major airports. Our aircraft was launching out of Long Island, so there was a possibility that there were clouds in between there and there, which prevented us from getting there and doing the flyover. But for Cincinnati, what we really ran into was COVID. 2020, it kind of disrupted everything. Well, it also disrupted a lot of planning for projects. And in Cincinnati, they had released the RFP, I think, in January or February or March. That got pushed back initially to April. By the time we were under contract, it was getting into late August. So that kind of had an impact on all that. As we were getting into that part, then we ran into some bad weather. So we were starting to look at, hey, are we actually going to be able to finish this project and collect that LiDAR that we needed in the leaf on stage by the time fall rolled around. So if it didn't, the whole project was going to get pushed probably till June or July the following season. So we really had an interest to getting it done, but you can't collect good data if the data is not there for you. And what I mean by that, if the leaves all fall off, we now no longer have that leaf on coverage. So we actually were able to finally get past some of this through some of this issues with the weather. The vendor we were using at the time was able to position aircraft and was ready to go as soon as the weather broke. But by the time the weather broke, we were looking at, some of the tree canopy had already started to fall. So what we did is we put our heads together and said, hey, what realistically, how long can we collect this data for before we're just going to have to scrap everything? And it really came down to, we decided between 80 and 90% of canopy. So we got some good weather. We were able to actually fly the whole thing, which could have been very well disruptive if we had gotten bad weather again. But we were able to collect the data and process. And what we did find, I think this was a key takeaway from the point, and our timing just happened to be perfect, but it would be very hard to really replicate that in any given project, was that when we actually flew it, there was enough canopy had fallen that we could still collect kind of the overall canopy that we wanted and get really good data. But we were able to get a lot more of those LiDAR returns to the ground, which meant that we were able to calculate the heights of a lot of these trees better. So I think a good takeaway from this project was the timing worked really well in our favor, which could have gone really bad and pushed the whole project for 6 or 8 months. But we really were able to collect much better data, still get that full canopy on the trees, and with a little bit less canopy there, get better heights on the trees that we were able to provide to the client, which we normally might not have done, but it gave us an extra deliverable we were able to provide kind of at no charge, basically, because we got much better data out of it.
For sure. And what you're looking at on the screen here is they had a previous flight from 2011 and then coming back, what would be 9 years later in 2020. And that was a crucial aspect of the analysis, is 2 different comparable data sets to then say, all right, what has changed over this almost 10-year period? And I think for so many communities, it's not necessarily just about having one coverage layer, but what are the trends? Where is it increasing? Where is it decreasing? Where do we need more? And that's really what was one of the output data products that I believe we have on the screen here. So we can actually compare those 2 scenes and identify where's the gain, where's the loss, where's the no change, and actually put that into some real decision making, because at the end of the day, that's what people are really curious about, is what are the neighborhoods that are at risk, or efforts on the ground that have been in place effective.
Yeah, Aaron, an important thing to note there too is that what we found was that as the client was looking at it, there were areas where, let's say, if you're looking at this image here where it says lost, they looked at it, some of these areas, and say, wow, yep, we expected that because they put it in development there, or they know that there was some major change there. But there were some other areas where this doesn't really make sense. We wouldn't have expected to see that, but they actually went out in the field and were able to field verify some of this stuff so that they really understood, like, okay, there was some tree loss here. And then they were able to understand why by looking at the imagery, but then they could target these areas and go out rather than having to scan the whole city and walk around and say, did we lose trees here or not? So this data was incredibly valuable to really look at, understand it, and then go target those areas to understand why there's a loss in tree canopy.
For sure. And I want to kind of bring that back to our last aspect. I mean, we've heard about what the technology can do and kind of where it's heading, but in terms of answering these real questions, the more even on the social issues, what are the aspects of the Cincinnati project that are going beyond, the identification of where the trees are themselves? what are the kind of things we learned as the consultant here about, the equity side and ultimately the goals that these communities have and the responsibility that they have to the public at large?
Sure. Well, I think it's probably no surprise that a lot of these disadvantaged parts of the communities, don't have the number of trees that some of these other areas that do. So as you get away from city centers, when you get to more residential type areas, you typically will see a lot more tree canopy. Where when you get places where there's subsidized housing or whatever, they build these big blocks of homes, cut all the trees down and leave it. But that leaves these areas without certain advantages to tree canopy. So a few of those things are air quality. So one of the things we looked at was correlating health issues such as asthma to tree canopy. So we were able to get health data from Cincinnati Children's Hospital. We'll be able to take that and look at, where are these general places that people are living and correlate that to the number of trees. We're looking at, populations of color and where they were compared to the trees. So we were able to actually see that and then map that and produce, maps to support what I think everybody probably knew anyway, but it gives them a better idea where they can focus, and see that, all right, some of these communities, they did see an increase in tree canopy and a gain. But as you mentioned earlier, you just can't put trees anywhere. So with an updated land cover data set, what we can actually do is look at that land cover and help plan for where can we plant trees to help, increase the canopy in these populations that we think it would be beneficial for.
Absolutely. So really a system-wide approach to identifying where the real opportunities are that are, data-driven, evidence-based approach. I think that's really empowering those, folks in local government to make a case for what, again, you say they probably wanted to do anyway, but now we have the data to really back it up and make the job of identifying sites quite a lot easier. And
But
I
most
did want
importantly, though,
to.
sorry, Aaron, one of the things I
Oh,
was
go
going to say
ahead.
is, but most importantly, is that they can see the change over time. So between the 2011 and the 2020 collects and processing and analysis, we can actually see, has it increased or has it decreased? And then you could help use that to inform those decisions going forward.
For sure. I think the only other big area I wanted to touch on was how this is all adjacent to heat island modeling. I don't believe that was a direct part of this project, but it sounds like we have all the ingredients to now go forward and look at a heat island approach. I mean, that's a real concern for a lot of metro areas, and it's a real health risk as well, as you identified. Um, and by combining these pieces here, I thought we had developed a very modern approach to heat island where not only do we know where the trees are, but even modeling aspects such as the shade of those trees at like a particular time of day gets quite advanced. So just kind of any thoughts on where that aspect of um, data is headed would be really interesting to um, share with our audience here.
Yeah, I think that's a good point. As that's, I think, one of the powerful things of GIS is you can actually take it and model some of those changes. If where the sun shines at any given point in a day, at any given point in the year, so you can look at those trees, you can take the heights of those and understand really how to model it so that you can say, all right, this tree produces this kind of shade at this kinds of at this point in the day, how much shade that's providing to places, and how that shade is really beneficial to the populations. And whether it's keeping things cooler or it's just a more serene environment, right? I think most of us, I know, at least me, I'm not a city guy. Going into the city, makes me anxious. It's the concrete jungle, right? But if you go into a lot of these city parks that they put a lot of work into, it's a nice serene place so people can go and relax. They can sit under a tree and get cool. And you see a lot of these cities, New York, Chicago, Philadelphia, these big cities where in the summer they get a lot of times 90, 95 degrees, and they start getting worried about the elderly population, right? Because they don't have air conditioning. They rely on it keeping their windows open, and then there's no trees to provide any of that shade. That makes that a much more vulnerable population than it might be on any given other time of the year.
Sure. I think it also helps planners set goals for new development, saying, hey, on this site, we want to have a minimum of, this many trees planted or maintained potentially. Because it's not just about planting the tree, it's about keeping it healthy, right? so that takes funding. I guess the last question I wanted to ask before we start to wrap things up is, funding these projects. Obviously, there's an expense there. How are cities getting smarter about, either where to find money or how to find greater return on these investments? I know Cincinnati had a little bit of that baked in, but I would also be curious to hear Jared's thoughts after.
Yeah. So I think the important thing about Cincinnati is that they had a couple of different programs. One, they had a program that was where they would give out trees to people. You go down, pick up a tree, and actually plant it for them, which certainly reduces the amount of city resources needed, which is a really popular program. But the other thing too is that they need to take care of a lot of these trees within the right of way, what they know, as street trees. And over the 10-year period or so, that they found that they had about a 500, I believe it was about a 500 acre increase in canopy from these street trees as they continued to grow and as they planted them. And that was one of the things as they were looking at the data, they're like, geez, this is really, looking at this canopy is much more impressive than we thought. And Cincinnati charges a linear fee per linear foot of frontage on roadways. And that money goes to help and take care, cut down trees that are potentially risk. It helps to plant trees, and it helps take care of that. But that program really need more funding to continue to increase in the canopy along the right of way and take care of these things. So by using all this data that they took that was derived from the NAPE imagery as well as LIDAR, the city was actually able to go, or the Parks Department was actually able to go to the city council, show this data and show the increase over that 10-year time and what that program was doing. And ultimately, they were able to raise that fee by about 10 cents a linear foot, which nobody thought was possible, but they really saw the benefits to what that money was going into, and they could actually, show the returns on their investment there.
Yeah, absolutely. I think data is really empowering in that sense, is that you can put your money where your mouth is and back up the claims you're making with evidence. And that's really at the goal of a lot of the analysis we try to do. I guess from your perspective, Jared, anything you want to share on the funding side of the fence and how communities are getting, creative with being able to kick off one of these projects would be, I think, valuable information to share.
Yeah, what we have seen for some of the smaller communities as well as the much larger, even statewide collections, is data can be used at so many different levels that you aren't just thinking about, okay, we need funding from our federal partners. We need funding from FEMA. We need funding from the USGS. There's power consortiums. There are independent power companies that they are very interested to know where trees are in relation to their power lines. You have public works, you have water departments. They are very interested in knowing if anything changed that affects their assets, their inventory, whether or not there is a reservoir that might be lower than they thought it was supposed to be, or it has some sort of change, not necessarily on the surface, but if your water level has changed dramatically, it might be a result of something underneath the water. And that can be assessed from topological LIDAR alone, or it could definitely be assessed using bathymetric or sonar data. There are universities, there are so many other ways to get some partnership, a little bit of funding here, a little bit of funding there. And it is a lot of work. It can take some real organization. It helps to have a central point of contact. And a lot of times it works out to everyone's benefit. They may not get absolutely everything that they wanted to get, but they're able to combine funds, combine it with a use case so that you're getting bits and pieces of what you absolutely have to have coming in over and over again. A lot of times that turns into multi-year collections where you're going out and they have partners who want to join that year, but maybe not the next year. And then you're getting data on top of data on top of data, building this legacy information that can be used in so many other scenarios. So it's not the easiest thing in the world to start up, but once it gets going, it can be a very powerful engine to building repetitive programs.
Absolutely. And I love how you mentioned a variety of departments there, because we're seeing more and more having a centralized hub for all this information is letting more groups take advantage of the same information. It's not getting in a data silo, right, within one department. And that's something that, especially I know at AppGeo, we like to make our data accessible, make it user friendly, and it just creates more value. So I just want to wrap up a little bit with some what I thought were key takeaways from the discussion, and then I want to save a little time for Q&A. We have at least one question, and feel free to ask more here as we're getting to that point of the presentation. But we've seen LiDAR be more ubiquitous than ever. I think practically some of the new cell phones that are coming out have LiDAR sensors in them. So like this is now a household technology in a realistic sense. And what we do with that is opening up so many doors. And again, the sensors are just becoming more and more capable. Higher resolution and higher sample rates are giving us a level of detail that we never imagined, several years ago. We heard about how coordinating these flights is kind of a tricky business, especially the more urban area you are. It's not just like flying a kite. And then lastly, having a partner can help give you the flexibility you need to adapt to what's changing. I mean, Sanborn has this real wealth of equipment and specialists on their within their quiver, and a partner like AppGeo has worked in a variety of environments and with a variety of clients on a wide range of projects. So by putting those pieces together, you can really give your project the best chance at success. So I do want to go into our Q&A here and give you all the opportunity to ask. Well, we have Brian and Jared with us. We had one question come in already, that is, have you combined infrared sensors for temperature with LiDAR to be able to classify land cover and conditions such as like moisture in the soil in more detail? Interesting question there, now that we can think about like multi-band cameras, for example.
Not a stupid question. I can say that infrared sensors have been combined with LiDAR as well as with imagery, but mainly it is used to identify hotspots along power lines. This is mainly a preventative measure so that you reduce the number of power outages, lines down, forest fires, that kind of thing. And it's been very big in the western half of the US. In terms of classifying land cover conditions like soil moisture, not so much. I know it's been discussed. We've had a few pilot programs as well as some information that has been gleaned off of other data sets, but something that's very interesting to deal with, and it does make sense, is the infrared sensors operate best at night. They can operate during the day, but it is complete blowout of the actual bands. Operating with LiDAR, which can operate at night as well, is something that would be very interesting to see the result of. You would get the reflectance from the LiDAR itself, as well as the infrared, and you could build that into a three-dimensional temperature map. I think you still would be probably better suited to have some form of color imagery collected during the day to go along with it. But you could gain a lot more information from the infrared on top of all the LiDAR and the imagery itself. So it would be something that would be a very interesting program, and I know I would love to do it.
Yeah, it does make me think back to the urban heat island example too, and that there's a lot of misconceptions around that as a concept. But when it's almost like the nighttime from a health perspective is even more critical than the day, because when you think of the urban environment, it's surfaces that hold in heat. So even when there's no more sun, you have a brick wall that's just emanating energy throughout the night, right? And I think that's where the infrared piece can really start to answer some questions about, if we could keep this building shaded during the day, now it's going to have a cooler temperature throughout the nighttime. And that's when people are trying to sleep. That's when they're indoors in their homes. So
it would be very interesting to see almost a heat change. Have two different scenarios where trees were there before and then they went away to show just how much that brick wall or sidewalk emanates the heat after the trees disappeared. Oh wow, we really needed that shading to reduce the overall temperature coming off in this area.
Absolutely. So these are certainly questions on the forefront of this field, and so thanks for bringing that to the conversation today. I think we are almost at time here, but I want to give a last opportunity to any other questions in the chat. We also have Jared and Brian's contact information if you'd like to open up a deeper conversation about anything that we talked about today, or just have more questions about LiDAR. All right.
Thanks so much, guys. We really
Yeah.
appreciate having you here. I don't see any more questions right now, but I'm glad that you put your contact information up there. Please feel free to reach out. And I think you're going to reach out and send a presentation or send information to all of the people who have registered today. So keep your eyes out for that. And again, I just want to thank everybody for joining us today. And thank you to all of you, Jared, Brian, and Aaron, for being here with us. We really appreciate it. And I hope to see you at another Lunch and Learn or an upcoming event at the Center for Watershed Protection. Thank you, guys.
Yeah, thanks, Karen,
Great,
for
thank you
having
very
us.
much.
Have a good day. Bye.